Hey Kim kids, welcome back. This is the back side of 12-4 homework. We just went through the front side, and now we're finishing up with the last two questions on here, which is translating from words to symbols with state symbols as well. Alright, so our first step when we go through and do this is to make sure and translate from words to symbols. So if we go through, I'm going to go through and highlight the things that needs to be translated to symbols. So we've got aluminum, oxygen, and aluminum oxide. So we've got to translate those from words to symbols. And so to do that, we've got aluminum, which is Al, and I'll put my dash out front to make sure I don't try to change a subscript. Reacts with is going to be plus. So I've got reacts with oxygen, and remember oxygen is a, diatomic molecule or a diatomic atom, which means whenever it's by itself it has O2 beside it. And then to form is going to be our arrow, and we're going to get aluminum oxide. Aluminum is Al and it's plus 3. O is -2. So we need to do our crisscross on here, which gives us a formula of Al2O3. Now, to make sure we don't get confused with those numbers later, we're going to actually lose those, but you've seen them, so they're there. All right, so that was step 1. Step 2, we're going to write our state symbols in. So elemental aluminum. Aluminum in its natural state is a solid, so we're going to put an S behind that. Then we've got oxygen gas, so we're going to put a G behind that. And last but not least, we've got solid aluminum oxide, so we're going to put an S behind that. So that was step 2, translate to state symbols, and that's given, what's given to us in the problem, if you will. And our last step is to go back and balance, so we'll finish this in blue. If we start with our ALs, we can do that, which is what it tells us to do. We have 2 ALs on this side, and we need 2, so we're going to put a 2 right there. Now we move to oxygens because we're going to save those for last. So I have 2 oxygens on this side and 3 on that side. Well, that's not going to work out, so if I put a 2 here, that gives me an even number of oxygens. That gives me 6 oxygens on this side, because 2 times 3 gives me 6 oxygens. That would be this 2 times that 3, which gives me 6 oxygens. So to get 6 oxygens on this side, what times 2 gives me 6? I put a 3 right there. That's really good, except for, our aluminum is now wrong because we put that 2 out front. So we have 2 times 2, which gives us 4. To solve that problem, we're going to put a 4 in front of the Al. So that is writing a balanced chemical equation. And the last part is to figure out what type of reaction this is. And so we have one product. If we have one product, that tells us that is a synthesis reaction. Okay, awesome. So far, so good. Let's move on to the next one, following those same steps that we just went through. So if we start off with highlighting our substances that need to change, we've got iron 3 oxide, reacts with carbon monoxide to form iron and carbon dioxide. So we've got to translate those from words to symbols. So iron 3 oxide, we've got Fe, which is plus 3, and that's because of that 3 right there. Oxide, which is -2. So we've got to do our crisscross and reduce there. So we get Fe2, Fe2O3, because we had to crisscross and get those numbers. So take a second, make sure you got that. All right, reacts with means we're going to put the plus sign there. Carbon monoxide. Hopefully we remember carbon monoxide, which is CO. Carbon monoxide, which is CO. And then we've got to form, so we're going to put arrow We've got solid iron. So that would just be Fe. That and there means plus. So we're going to put plus carbon dioxide, which is CO2. So that is our first step, translating from words to symbols. Our next step is to be adding in our state symbols. So we've got solid iron 3 oxide. So behind Fe2O3, we're going to put S in parentheses. Then we've got carbon monoxide gas. So behind CO, we're going to put gas, or G in parentheses, to form solid iron. So we're going to put an S there. And carbon dioxide gas. So we're going to finish it with a G right there. All right, that's our second step. Our third step now is to balance. This one's actually a tiny bit tricky, but it's okay. We can handle this. All right, so if we start off with our FEs, all right, we have 2 FEs, 1 FE. So I'll put a 2 out front there to balance my FEs, which brings us to our O's. Or C's, excuse me. Our C's are actually good. That's why I skipped them. All right, now our O's. We have 3 plus 1 gives me 4 O's on this side. All right, on this side, we currently have 2 O's. So how do I get 4 O's? Well, I can put a 2 right there, which now gives me 2 C's and 4 O's. So 2 C's, 4 O's, and lose that. So now we've got to go back and fix this because we added an amount of O's that we can't get over here. Because if we add a 2 right there, that gives us 2 C's and 5 O's, which we're not quite balanced with. So we've got to try something else. And remember, writing balanced chemical equations is really just about experimenting. So let's go back to the beginning. All right. And let's try a 3 right there, because that can get me 6. And now I should be able to get 6 on this side, because I have 3 C's and 6 O's and 1 FE currently. But if we go over here to get 3 C's over here, if I put a 3 right there, that gives me 3 C's, but that also gives me 3 plus 3, which is 6 O's. And now all I have to do is fix my FEs. There's 2 there. Put a 2 right there. We're back to good. 2 FEs and 2 FEs on this side. All right. If we want to finish that with a 1, we can. But a little bit tricky, but we can handle that as well. Now, the type of reaction on this one, it's a little bit tough to see. All right. But technically, we would call this a single replacement. All right. Single replacement. And that's because we had oxygen in both sides right here. We had oxygen here and here. And then they just ended up going together. But again, I won't count this one wrong no matter what you get here. Okay? Awesome. Thanks. See you next time.